Hey there everyone, and welcome to a short video series for React Month. In this two-part series, we'll be diving into a library that calls itself the modern monolith of web development. Its name is Inertia.js. If you've ever worked with any kind of traditional model view controller web framework before, like Laravel, Ruby on Rails, or ASP.NET MVC, I think it will interest you. This video is part 1 and we'll be covering what Inertia.js is and how it works in detail. In the second video, we'll dive into building something small with it. So what is Inertia.js? At its core, Inertia.js is a library that allows you to build single-page applications without the need to create an API, which can dramatically simplify the process of creating your app. It acts like glue between your front-end and back-end, allowing you to make use of server-side routing and controllers to create pages that are rendered client-side as part of a single-page app. Inertia.js can work with any backend and supports React, Vue, and Svelte on the front end. Now, typically, when building a single-page app, that app will act as a client and load up a single HTML web page, which then fetches data via HTTP requests. Whatever client-side web framework you are using will use that data to generate HTML on the client that the user can see and interact with. As the user interacts with the app, no more full page requests are made, and the application is updated by continuously fetching more data. This is known as client-side rendering. It leads to a very smooth app-like experience. The traditional web application is the opposite of an SPA. It's sometimes called a multi-page app. A request for a page is sent to the server will route the request to the correct controller, which will read data from some sort of model. The data is then placed into a Vue template and sent back to the client as HTML. This style of app has been around for much longer and tends to be more simple to build compared to an SPA. All navigation will trigger a full page load, so you don't get the app-like experience of an SPA. So Inertia.js kind of blends these two methods together. When you're using Inertia.js, you can build your app with whatever your favorite server-side framework is. All of the functionality for core things like data fetching, middleware, controllers, authentication, and authorization will stay exactly the same. Inertia.js replaces your app's view layer. Instead of returning HTML from whatever templating engine your server-side framework uses, the views returned from your server will be JavaScript page components. On the client side, these are then rendered to produce your view. This allows you to build all of your front end in React, Vue, or Svelte while using all of the functionality of your server-side framework. Now, just returning page components won't give you that smooth SPA-like experience. If you were to click a link, your browser would make a full page request, causing your client-side framework to reload your entire application. This is where Inertia.js comes in. At its core, Inertia.js is essentially a client-side routing library. It allows you to make page visits without forcing a full page reload, just like your typical single-page app. To do this, it provides a link component that wraps the normal HTML anchor link with added functionality. When you click an Inertia link, Inertia intercepts the click and makes the visit via an XML HTTP request instead, kind of like you would if you were making an API call. When Inertia makes that request, the server detects this and sends back JSON containing the page component to load and its props instead of HTML. Inertia then swaps out the current page component for the new page and updates the browser's history state. This all comes together to give you an SPA-like experience with no API. Inertia.js can work with any backend because it specifies a protocol that servers can implement to support its front-end library. Inertia calls these server-side implementations adapters, and it provides an official adapter for the PHP framework called Laravel, and a list of community-created adapters for other languages and frameworks. I'll step through the protocol now, and in the next video show a basic adapter I implemented in Go. So the very first request to an Inertia app will be a full page request with no special headers. The server will return a full HTML document with all the site assets you need to load your app and client-side framework. So that means any CSS and JavaScript files. The HTML returned needs to have a root div component in the This is where the application will be mounted. The data page attribute should have a JSON page object with the component and props for the page. Inertia will use this to load your client-side framework and display the page component. Once your app is loaded, all following requests to the site are sent via XML HTTP request with an X-Inertia header set to true. When the server detects the X-Inertia header, it must respond with a JSON payload containing a page object. Data about the page is sent to the client through a page object. The object has information that's used to render the page, update the browser history, and keep track of the site's asset version. The page object has a component property, which is the name of the component to load, a props property, which is the props object that is passed to the page component, a URL property, which specifies the URL of the page, and a version property, which is the current version of the site's assets. Inertia.js keeps track of your site's assets with an asset versioning key. The page object has a version property, which is set server-side. It can be any value, a number, a string, or a hash, as long as it changes when the site's assets have been updated. When Inertia requests are made, the current asset version is sent under the X-Inertia version header. When the server receives the requests, it compares the asset version in the header with the currently set asset version on the server. If the asset versions match, the page request continues as normal and the server returns a page object. If the asset versions are different, the server returns a 409 conflict response and includes the URL in an X-Inertia location header. Inertia will read this response and make a full page request to get the new site assets. This 409 response is only sent for GET requests. Inertia also supports making partial reloads. This allows you to request a subset of props from the server for a page component that is already loaded. It can be a useful performance optimization if you are able to reuse data. When you make a partial reload request, Inertia includes two additional headers: X-Inertia partial data and X-Inertia partial component. The X-Inertia partial data header is a comma-separated list of the props that should be returned, and the X-Inertia partial component header includes the name of the component that's being partially reloaded. This is needed since partial reloads only work for requests made to the same page component. The server will respond with the data, and Inertia will update only the props named in the X-Inertia partial data header. And that's it for part 1. Thanks for watching, and in the next video I'll be diving into implementing some of the Inertia protocol with the Go programming language as a backend.